UL issued a warning regarding a potential electric shock hazard associated with certain portable ground fault circuit interrupters, or GFCIs. This hazard arises when the GFCI is not correctly plugged into a grounding type receptacle. A GFCI is designed as a safety device to protect individuals from electric shock. It functions by interrupting the flow of electricity when a ground fault occurs. A ground fault is a situation where electrical current deviates from its intended circuit path, potentially flowing through a person or an appliance. UL has identified that certain portable GFCIs, when not properly connected to a grounding type receptacle, may fail to trip in the event of a ground fault. This failure could lead to an electric shock. To mitigate this risk, UL recommends several precautions. Firstly, always ensure that the GFCI is plugged into a grounding type receptacle. A grounding type receptacle is identifiable by its 3 prongs, 2 flat prongs and 1 round prong, with the round prong serving as the grounding connection. Secondly, regularly test the GFCI. To test it, press the test button located on the device. The GFCI should trip, effectively interrupting the flow of electricity. If the GFCI fails to trip during this test, it indicates a malfunction and should be replaced immediately. Thirdly, replace any GFCI that is not functioning correctly. A faulty GFCI should not be used under any circumstances. UL is collaborating with manufacturers to address this issue and prevent similar hazards from occurring in the future. For further information on GFCIs, consumers can visit UL website or contact UL Consumer Safety Hotline. Grounding type receptacles are a critical component of electrical safety. The grounding system provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and interrupt the circuit. Without a proper ground, a fault current could flow through a person touching a faulty appliance, resulting in a potentially fatal electric shock. The grounding prong on a grounding type receptacle is connected to the grounding wire in the electrical system. This wire runs back to the main electrical panel and is connected to the grounding electrode system, which is typically a ground rod driven into the earth or a metal water pipe. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provides a path for fault current to flow. When a ground fault occurs in an appliance, the fault current will flow through the grounding wire back to the main electrical panel. This will cause the voltage on the grounding wire to rise, which will trip the circuit breaker or fuse, interrupting the circuit and preventing an electric shock. Ground fault circuit interrupters, or GFCIs, are designed to provide an additional layer of protection against electric shock. GFCIs work by monitoring the current flowing through the hot and neutral wires in a circuit. If there is a difference of more than a few milliamps between the current flowing through the hot and neutral wires, the GFCI will trip, interrupting the circuit. This difference in current indicates that some of the current is flowing through an unintended path, such as through a person. GFCIs are particularly effective at preventing electric shock in wet or damp locations such as bathrooms, kitchens, and outdoor areas. In these locations, the risk of electric shock is higher because water can provide a path for current to flow through the body. The National Electrical Code, or NEC, requires GFCIs to be installed in all new construction and renovations in certain locations, including bathrooms, kitchens, garages, and outdoor areas. Portable GFCIs are commonly used in situations where a permanent GFCI is not available, such as when using power tools outdoors or when working in a construction site. However, it is important to ensure that portable GFCIs are properly plugged into a grounding type receptacle to ensure that they will function correctly in the event of a ground fault. When testing a GFCI, it is important to follow the manufacturer's instructions. Typically, the test button is pressed to simulate a ground fault. The GFCI should trip immediately, interrupting the flow of electricity. If the GFCI does not trip, it should be replaced immediately. It is also important to periodically inspect GFCIs for any signs of damage or wear. If a GFCI is damaged, it should be replaced immediately. Replacing a GFCI is a relatively simple task that can be performed by a qualified electrician or homeowner with basic electrical knowledge. However, It is important to follow all safety precautions when working with electricity, including turning off the power to the circuit before beginning any work. When selecting a GFCI, it is important to choose a model that is listed by a recognized testing laboratory, such as UL. This ensures that the GFCI has been tested and meets safety standards. It is also important to choose a GFCI that is rated for the appropriate voltage and current for the circuit in which it will be installed. GFCIs are an important safety device that can help to prevent electric shock. By following the recommendations of UL and the NEC, consumers can help to ensure that GFCIs are properly installed and maintained, and that they will function correctly in the event of a ground fault. The grounding system in an electrical installation is designed to provide a low impedance path for fault current to return to the source, thereby facilitating the rapid operation of overcurrent protective devices such as circuit breakers or fuses. This rapid clearing of the fault minimizes the duration of potentially dangerous voltage exposures to people and equipment. The grounding system consists of several interconnected components, including the grounding electrode, the grounding electrode conductor, the equipment grounding conductors, and the bonding jumpers. The grounding electrode is a conducting object such as a ground rod or a metal water pipe that is buried in the earth and provides a connection to ground. The grounding electrode conductor connects the grounding electrode to the neutral bus in the main electrical panel. The equipment grounding conductors are wires that run with the circuit conductors and connect the metal enclosures of electrical equipment to the grounding system. Bonding jumpers are used to connect different metal parts of the electrical system together, ensuring that they are all at the same potential. The National Electrical Code, or NEC, provides detailed requirements for the design and installation of grounding systems. These requirements are intended to ensure that the grounding system is effective in protecting people and equipment from electrical hazard. One of the most important requirements is that the grounding system must be properly sized to carry the maximum fault current that could occur in the system. The size of the grounding conductors and bonding jumpers must be based on the size of the overcurrent protective devices in the circuit. Another important requirement is that the grounding system must be properly installed. All connections must be tight and secure, and the grounding conductors must be protected from physical damage. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock by detecting ground faults and interrupting the circuit. A ground fault occurs when current flows through an unintended path to ground, such as through a person touching a faulty appliance. GFCIs work by monitoring the current flowing through the hot and neutral conductors in a circuit. If there is a difference of more than a few milliamps between the current flowing through the hot and neutral conductors, the GFCI will trip, interrupting the circuit. GFCIs are required by the NEC in certain locations such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. There are two main types of GFCIs: receptacle type GFCIs and circuit breaker type GFCIs. Receptacle type GFCIs are installed in place of standard electrical receptacles and provide GFCI protection to the receptacle and any other receptacles that are wired downstream from it. Circuit breaker type GFCIs are installed in the electrical panel and provide GFCI protection to the entire circuit. When selecting a GFCI, it is important to choose a model that is listed by a recognized testing laboratory, such as UL. This ensures that the GFCI has been tested and meets safety standards. It is also important to choose a GFCI that is rated for the appropriate voltage and current for the circuit in which it will be installed. GFCIs should be tested regularly to ensure that they are working properly. To test the GFCI, press the test button on the device. The GFCI should trip, interrupting the circuit. If the GFCI does not trip, it should be replaced immediately. Electrical safety is a critical concern in any environment, whether it's a home, a workplace, or a public space. Electricity is a powerful force that can cause serious injury or death if not handled properly. Understanding the principles of electrical safety and following safe practices is essential for preventing electrical accidents. One of the most important aspects of electrical safety is to be aware of the hazards associated with electricity. These hazards include electric shock, electrocution, fire, and explosions. Electric shock occurs when a person comes into contact with an energized electrical circuit. The severity of the shock depends on the amount of current flowing through the body, the path of the current, and the duration of the contact. Electrocution is a fatal electric shock. Fires can be caused by electrical faults, such as short circuits or overloaded circuits. Explosions can be caused by flammable materials igniting due to electrical sparks. To prevent electrical accidents, it's important to follow these safety tips. Firstly, never touch electrical wires or equipment with wet hands. Water is a good conductor of electricity, so touching electrical components with wet hands can increase the risk of electric shock. Secondly, use only electrical cords that are in good condition. Frayed or damaged cords can expose live wires, creating a shock hazard. Thirdly, don't overload electrical outlets or circuits. Overloading can cause the wires to overheat and start a fire. Fourthly, use ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms and kitchens. GFCIs are designed to protect people from electric shock by detecting ground faults and interrupting the circuit. Fifthly, have a qualified electrician inspect your electrical system regularly. An electrician can identify potential hazards and make repairs to ensure that your electrical system is safe. Sixthly, be careful when working near power lines. Stay at least 10 feet away from overhead power lines and never touch a downed power line. Seventhly, teach children about electrical safety. Children should be taught not to play with electrical outlets or cords. Electrical safety is everyone's responsibility. By following these safety tips, you can help to prevent electrical accidents and protect yourself and others from harm. The Underwriters Laboratories, or UL, is a global safety science organization that tests and certifies products to ensure that they meet safety standards. UL mission is to promote safe living and working environments by applying science and engineering to prevent accidents, injuries, and property damage. UL tests a wide range of products, including electrical appliances, electronics, fire protection equipment, and building materials. UL certification marks are recognized worldwide and indicate that a product has been tested and meets UL safety standards. UL also provides training and education programs on safety topics. UL website is a valuable resource for information on electrical safety and other safety topics. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is adopted by most states and local jurisdictions in the United States. Compliance with the NEC is essential for ensuring the safety of electrical installations. The Occupational Safety and Health Administration, or OSHA, is a federal agency that is responsible for ensuring the safety and health of workers in the United States. OSHA sets standards for workplace safety and health and conducts inspections to ensure that employers are complying with these standards. OSHA has a number of standards that address electrical safety in the workplace. These standards cover topics such as lockout, tagout, personal protective equipment, and safe work practices. Compliance with OSHA's electrical safety standards is essential for protecting workers from electrical hazards. Electrical safety is a critical concern for everyone. By understanding the hazards associated with electricity and following safe practices, you can help to prevent electrical accidents and protect yourself and others from harm. Always prioritize safety when working with electricity, and never hesitate to consult with a qualified electrician if you have any questions or concerns.